The Ganga River spans 2,525 kilometers, functioning as the primary drainage system for a massive portion of the Indian subcontinent. Public understanding of this entire system is often anchored to a single mythological origin point located deep in the Himalayas. While the Gomukh Glacier is traditionally cited as this source, geographical data shows it is only one small component of a much larger network. The river lacks a singular point of inception. It exists as a composite entity, assembled through a series of high-altitude mergers. Every turn in the basin is dictated by a rigid framework of strict hydrological laws, deep tectonic fractures, and extreme topological gradients. To understand the system's behavior, we must reconstruct the river from the highest bedrock down to the coastal delta. Mapping the Ganga Basin involves reverse engineering a continent-scale hydrological machine, tracing every mechanical input from the peaks to the plains. Our model begins in the Garhwal region of the Himalayas, where seasonal glacial runoff generates dozens of high-velocity streams. These streams merge by a strict hydrological law. The deeper river absorbs the shallower channel and keeps its name. We trace the Alaknanda River from Badrinath as the primary baseline channel. Moving south, it absorbs 4 major tributaries at junctions known as the Priyaks. At each of these first 4 junctions, the Alaknanda possesses the superior depth, allowing it to survive every collision with its identity intact. To the west, the Bhagirathi River emerges from the Gomukh Glacier, carrying a massive volume of glacial melt toward the Alaknanda. Human engineering intercepts this volume high in the mountains, harnessing the river's kinetic energy before it reaches the lower valleys. This energy is captured by the Tehri Dam, the tallest dam in India. Because this structure is located upstream of the final confluence, it sits strictly on the Bhagirathi River, rather than the Ganga. At Devprayag, the mighty Alaknanda and the Bhagirathi finally collide in a high-volume junction. This specific junction presents a hydrological anomaly. Both rivers arrive with virtually identical depths and flow volumes. Without a dominant depth, the naming convention resets. The merged waters take an entirely new name, the Ganga. The Ganga is the mathematical outcome of the hydrological equilibrium achieved here at Devprayag. After leaving the steep Himalayan valleys, the Ganga hits the flat terrain of Hardwar, marking a significant topological shift. This sudden drop in gradient causes a physical shock to the river, dropping its velocity from a mountain torrent to a slow crawl. On the left bank, tributaries like the Kosi River enter the system after descending from the extreme altitudes of Nepal. The Kosi possesses immense kinetic energy, allowing it to violently carve through mountain rock and carry millions of tons of heavy sediment downstream. Hitting the flat Bihar plains, the river loses velocity. Heavy debris drops out of suspension, clogging the channel. This sediment buildup forces high-pressure water to break through the banks, carving a completely new, unpredictable channel through a process called channel avulsion. Avulsion results in catastrophic, instantaneous flooding in rural areas that had no prior river channel to manage the flow. This frequent, destructive behavior has earned the Kosi the title, the Sorrow of Bihar. These floods are not random events, but the mechanical failure of a river system struggling with a sudden collapse in gradient. To the south, the right bank tributaries join the Ganga from the peninsular plateau. Surface water here is governed by a natural east-west slope, which dictates the gravitational flow. The Son River, originating in Madhya Pradesh, represents a major exception to this rule. The Son flows directly north, moving against the natural subcontinental gradient to reach the Ganga. Forged by ancient tectonic collisions, deep rift valleys were created. Trapped inside this structural fault line, the Son River is walled in on both sides. The rift acts as a natural trench, forcing water north until merging with the Ganga. The river's path reveals the million-year-old tectonic scars that remain hidden deep beneath the surface. Moving through Jharkhand and into West Bengal, the Ganga carries the entire basin's accumulated water. At sea level, the river's kinetic energy dissipates, causing the flow to split into 2 main distributaries, the Padma and the Hooghly. The Hooghly branch flows south through India, sustaining the Kolkata port, a critical hub for regional trade. This port is threatened by millions of tons of silt that have traveled 2,000 kilometers. In the slow-moving Hooghly, this silt settles, threatening to choke the channel. To prevent this, engineers constructed the Farakka Barrage just before the Bangladesh border. Farakka operates as an active diversion system, specifically engineered to redirect the river's flow rather than static water storage. It artificially forces a massive volume of additional water down the Hooghly, acting as a hydraulic flush that blasts accumulated silt out into the ocean. Modern economies now rely on the physical mechanization of the river's flow to manage the compounding weight of its own sediment. The fully constructed 2,525-kilometer basin serves as a massive engine for water and sediment transport. This material ultimately builds the Sundarbans, the largest river delta on Earth. We can measure the health of this entire geological system by monitoring specific bioindicators. These include bacteriophages that consume pathogens, and the Ganga River dolphin, a blind apex predator that requires highly oxygenated, unpolluted water to sustain its metabolic functions. Because the dolphin's biology is intolerant to even moderate chemical shifts, its presence provides an immediate, reliable diagnostic of the system's ecological integrity. The Ganga is not a static line on a map. It is a sensitive, interconnected machine where tectonic shifts and polluted tributaries determine the survival of the entire subcontinent.